6.1, the law of sines. We know how to find missing angle measures and side lengths in a right triangle. Now we're going to learn how to find missing side lengths and angles in triangles that are not right triangles. And so the law of sines is one of those ways we can do that. So if A, B, and C, capital, are the measures of the angles of a triangle, and lowercase a, b, and c are the lengths of the sides opposite these angles, then a over the sine of a is equal to b over the sine of b, which is equal to c over the sine of c. Now you're not going to be doing all three of these at once. You might do this proportion, or you might do this proportion, or you might do this proportion. For example, solve the triangle with A, 62 degrees, C, 84 degrees, and lowercase c, 18 centimeters. You're going to need to draw a picture. So the lowercase side A is opposite the angle A. Lowercase side C is opposite the angle C. And then angle B would be opposite the lowercase b. We can find the measure of angle B right away because we know that there are 180 degrees in the three angles of a triangle. So go ahead and do that right away. So the measure of angle B will be 34 degrees. The next thing we want to try to figure out is the length of side A. So using the law of sines, A over the sine of 62 degrees is equal to 18 over the sine of 84 degrees. Then you're going to cross multiply. So you're going to punch in your calculator the sine of 84 degrees, making sure you're in mode degrees, multiply it by A, and that's where I'm getting this. Then, making sure you're in mode degrees, take 18 times the sine of 62 degrees, and then that's how I get this. Then take 15.893 and divide by 0.9945, and that will give you the length of A is approximately 15.98. We can repeat this to find lowercase b, the side that's opposite angle B. We already found angle B to be 34 degrees, so we're going to use lowercase b over the sine of 34, and then you can pick whichever ratio you want to use. You can use side C over the sine of C, or I could have used side A that I just found over the sine of A. Either one will work out. And then you cross multiply. So take the sine of 84 degrees, and that's how I'm getting this. And then take 18 times the sine of 34 degrees. That's where I get this. Then take this divided by this. And then I get B to be 10.12. So once you know all three angles and all three sides, you have solved the triangle. In example 2, we want to solve the triangle if A is 42 degrees, C is 21.5 degrees, and B is 13. Once again, draw a picture. Fill in what you know. If they give you two angle measures, you can immediately use the fact that there are 180 degrees in a triangle and find the measure of angle B. Then you can set up your ratios to find the rest. I'm going to set up 13, which is side B, over the sine of angle B is equal to A over the sine of angle A. Cross multiply. So that's going to give us this. This is the sine of 116.5 degrees. This is 13 times the sine of 42. Take this, divide it by this, and then you'll get A to be 9.72. And then repeat the law of sines again to find the missing side C. Side C over the sine of angle C is equal to side A over the sine of angle A. Cross multiply, so take the sine of 42 degrees times C, and this is the sine of 42 degrees times C, and then this I get from taking 9.72 times the sine of 21.5, then take this, divide it by this, and I get C to be 5.32.